Okay, so now it's 11 o'clock, so let's get started. I can see, so today we're going to start our session 3 of our Python class. Now we're 1/3 of our way to the end. And from our warm-up, I can see one question. Can we review the range function? Okay, let's review that. So recall that range, when I type in range, I get, it gives me a sequence. So if I did range 1, 100, this would give me a sequence from 1, starting from 1, going all the way up to, but not counting 100. So if I did, and if I wanted to go through that sequence, I could go through it using a for loop like this, and then I could say 1, 100 like that, and then if I print it out, this would print out all the numbers from 1 to 99, like that. And if we wanted to count by different numbers, we could add a third number in the range parentheses, like if we wanted to count by 2s, let's say. And then I said print I. Can anyone guess what this would do? So what would this function here do? Or this, these two lines? Okay, yeah, so it would print out all of the odd numbers between 1 and 100, like that. Okay. So now let's, so today we will be talking mostly about dictionaries. So dictionaries in Python are, they're one of the best Python data structures that you'll ever really use. They have an O of 1 complexity, so they're pretty efficient. They're very efficient, in fact. And they achieve an O of 1 complexity using a technique called hashing. And in a dictionary, we map a key to one value. So each variable that we call a key will map to another value in Python. So as you can see here, we have a dictionary, an example dictionary for different prices of different groceries, I guess you could say. So here we have a string called bread, and then so here we have a string called bread, and then this maps to the float value of 1.78, and then we have a string called candy, and this maps to the float value of 0.50, and then we have a string here called soda, which maps to 1.00. Or we can just do closed, two curly brackets closed together like this, and then this would give us a empty dictionary. So we can okay, so we can also, so the way we can also make a dictionary like this, where we have our variable name over here, and then we have we use what's called the we can explicitly define it. So here we have DICT for dictionary, and we can also create a dictionary like this. So in this dictionary, banana, the string banana will map to the string yellow, and the string apple will map to the string red. And so basically what a dictionary does is it maps our keys here. So here the key is bread, the string bread, and then this key will map to the value of 1.78. And then, and so on for other keys that we use. And another important thing about dictionaries is dictionaries were always unordered. So if I were to make bread, candy, soda, and then let's say I was adding these values to a dictionary, then all of these would be unordered. I wouldn't be able to control the order that these would come in the dictionary. So, but this was until Python 3.6 came out. So now you can use, so now in Python 3.6, dictionaries started to become ordered. They started to stay in the order that you added the values in. But since you might think that this is a great thing, right? Because now dictionaries are ordered, before they weren't ordered, but this can actually be problematic. So let's say you wrote a Python program that used a dictionary for some task, and then you were trying to run that Python program on other people's computers, or you tried to publish it. Then let's say that those other people, they weren't using Python 3.6, like maybe they were using something like Python 3.5. Then they'd have errors in their program because their dictionary wouldn't be ordered the same way as yours were, assuming you're using Python 3.6. So if you want to preserve the order of a dictionary, it's recommended to use what's called an ordered dict, which you can import from collections, and I'll show you how you can import things in Python in just a sec. So first of all, can everyone see this screen here? Okay, so if I wanted to import something, all I'd have to do is just type in import, and then we'd import what we call packages into our command prompt. So let's say I wanted to import the math package, right? Like that. So now I can do things like math.random, I believe. Or no, I think it's import random. So now I can do random use random. Okay. Oh, whoops. Okay, so rand int, this basically generates a number, a random number between the two values I give. So like that. So this time I got 1. So you know it will generate random numbers every time you run it. So let's go back to our presentation. And so let's say I wanted to import an ordered dict. So how I do that is I go to my Python and then I type in from collections, because that's where we're importing ordered dict from. And then we say from collections import, and then the name of what we're importing. So in this case, we're importing this. So now I can create an ordered dictionary the same way if I were to create a regular dictionary. I just use a different keyword. Okay. Okay, so the way, if you wanted to use the dictionary, like let's say you wanted to look up one of your key values, right? So let's say you were looking up the string candy, and then what you do is you just write it like this. So you type in the name of your dictionary variable here, and then in brackets, you type in the key value. And then this would return the value of your key, essentially. Hold on just a sec. Okay, sorry about that. Anyway. So you can also cycle through a dictionary like this. So here we have, so this is using a for loop to cycle through a dictionary. So we have our key and our value for KV, key value in our dictionary here. And what this will do is this will just basically cycle through the dictionary through all the key values in the dictionary. And then if we wanted to add a value to our dictionary, we'd use the .update function, which would update the key value and then the value of the key and then the value of that key. Another thing to be careful of is when we're using floats. And we'll go over that in just a second. But another thing you can do is you can type in your key and value in your dictionary variable name, and this will also cycle through it. So remember how when we're using for loops, we cycle through some sequential data, right? So if I said for I in range, and then 100, like that, and let's say I'm printing out I, then this will cycle through the range, right? We'll cycle through So I is going to cycle through this value here. But remember, range isn't the only thing we can cycle through. We can also cycle through other sequential data structures like strings. So if I had the string A, B, C, D, E, F, like that, and then I'm doing the same thing, like this, we're still going to cycle through all of them. And then dictionaries just happen to be another sequential data that you can cycle through. Another thing to another thing you can use is the dot items and the dot values. So what this will do is this will return a set of all the items in your dictionary and all the values. So items mean the keys and the values, and the dot values meaning just the values. And here, I'll show you how that looks. So let's say we're making a dictionary called dictionary, like that. So this is just a variable name. It's lowercase. So now let's make our entries for our dictionary. So in this case, we're going to do, let's say we're going to use these same, let's just use these entries. Like that. So now if I typed in dictionary like this, then it would give me this dictionary here. So if I wanted to, let's say I wanted to find the price of, I don't know, maybe how about bread, like that, then it would give me the price of bread according to my dictionary, like this. So you can see that there are ways to make this user friendly too, right? Like maybe you're asking the user for something, maybe like this. So type in an item, so lookup, and then what we do is we just type in the item that we want to look up, the price at. So maybe I'm typing in bread, like this, and then wait, we have to assign this to a variable first. So let's say I is equal to this. Oops. Like that. Okay, and then maybe I'm typing in bread. So now I can do, I can just look this up in the dictionary that we just made. So dictionary, dictionary of I, and this will give the price of what we just typed in. So does everyone understand how dictionaries work so far? Okay, so we'll go over updating a dictionary. So to update a dictionary, remember, we just use our dot update function like this. So we have bread and what else was it? Bread, candy, and soda. Maybe maybe we want to add something like, I don't know, how about coffee, right? Coffee, and let's say that coffee will map to, maybe let's say coffee costs $2, like that. Whoops. Okay, so like this. So now if I typed in dictionary and then coffee, then I get our newly updated value. And if I wanted to print the dictionary, or let's not print it out, let's just see. So now we have coffee added to our dictionary here. Okay, so anyways, what's wrong with floats, right? We have, we said that floats be careful when using floats. The reason for that is maybe you wanted to, I don't know, maybe your dictionary maps different. Let's make a dictionary here. And let's say that your dictionary will map maybe a float like 0.789 to maybe another float, or maybe to an int like 1, like that. So now maybe, or no, let's say that you're doing points. Say your float here is 0.1 plus 0.1 plus 0.1, like this. And so from what you already know about Python, what do you think would happen if I typed in, if I did this? What do you think would come up? Type in the chat. So can anyone guess what would come up if I typed in this, if I hit enter right now? Okay, so so from what you already know about Python, you might think that if I typed in d of 0.3 like this, then I'd get 1, right? Like this, because here I have 0.1 plus 0.1 plus 0.1 like this. And from what you'd already know, you might think that this would give out the value that we're mapping this to, right? 1. So that would be the intuitive way. But actually in Python, this isn't the case. It's right now here, we're getting a key error because the value 0.3 doesn't exist in our dictionary. So let's print out the dictionary like this. And you can see here we have 0.30000, and then all the way to, and then at the end we have a 4, right? Like this. So, but we typed in 0.1 plus 0.1 plus 0.1, which would give us 0.3, right? Using common math knowledge, right? So what's wrong with floats? So in Python, floats try to get the maximum precision possible. So that's why when we type in 0.1 plus 0.1 plus 0.1, we get 0.300 all the way to 4. This might make you feel a little sad that if I typed in 0.1 plus 0.1 plus 0.1, and then I'd say equals to 0.3. So what we just said, what do you think would come up if I did this? If I type this in? Yeah, this would be false because 0.1 plus 0.1 plus 0.1 in Python is not 0.3 exactly. The reason for this is because floats try to get can only get up to this much precision. They want to be as perfect as possible, but Python's max precision for floats is only up to here, and that's why we get a 4 there. So this is something to be really careful about whenever you're creating a program, because this is what a lot of people make mistakes in a lot of times. So the way you can fix this is by doing round and then 0.1 plus 0.1 plus 0.1. So this will round the precision of this value, and then you'd write a comma here, and then you'd say the number of places you'd want to round this precision by. So here, if I want to just to get the second value, the second value in this equation, I type in 2, and then I just get 0.3, which is the answer we were hoping for. If I wanted to type in 3, this would still give this value, because this would just be 0.300, which in Python is just 0.3 without the zeros. So this is really helpful, especially if you're working in maybe chemistry or something like that, where you'd want to pay attention to the significant figures in your equation. So this is something to keep in mind. Okay. So what this does is this just normalizes your value to a lower precision. Okay. So O notation. There's more to O notation than what we already covered. So recall that big O notation was where we'd have so far we went over O of 1 and O of n, which O of 1 was the most efficient the best case or the best possible efficiency as far as we're concerned. And we could achieve O of 1 by finding the value of a dictionary key. So recall that dictionaries use hashing, a technique called hashing. And so we have O of 1 complexity in a dictionary. So that's why it's O of 1. And in O notation, we only take the term with the highest exponent only. Constants can never exist in O notation unless it is 1. So both of these are really important things to keep in mind. So if I had maybe, let's say I had, actually I'll type it in here. So let's say I had a for loop for I in range 10, and then maybe I'm printing out I, right? So this is printing out I 10 times. So you might think that, oh, this is going through this line 10 times. So this must be O of 10, right? But that's actually not the case. As far as we're concerned, this would be O of 1, because this line will take place 10 times every single time we run this program, no matter what the user types in, or no matter what if any values change. This will always occur the same number of times. So this will always run 10 times, right? So I can run it as many times as I want, and this will always run the same, approximately the same time every single time. So that's the best efficiency in programming as far as we're concerned, and it's called O of 1. So does everyone understand O of 1? And what O of 1 is? It's the best efficiency. So does everyone understand that? Okay, so nobody said no. I'm going to assume that everyone understood it. And so next we have O of n. O of n, what O of n does, it depends on, we're not able to know the efficiency of what O of n means is we don't know what the efficiency of our algorithm will be, because it depends on some underlying value. So recall that before we said that if I took in an input like this, and let's say our input is an int, and maybe I'm going to say type in a number, that, and so, oops. And maybe let's put this in the variable called, let's call this variable O, okay? So O is going to be the number that we type in. So maybe O is, let's say O is 0, and then for I in range O, we're going to print out X. So in this case, this for loop won't even run, right? Because O is equal to 0. That's what we typed in here. But we don't know that, right? It depends on what, well, or at least none of you would know that, because it depends on what I type in as a user, right? So if I could type in 700, or I could as easily type in maybe like 9,000 or something. And so it depends on what I type in. It depends on what the value of O is for this, that determines how many times this program will run, how long this program takes. So if I typed in, maybe something like 10,000, so what we had before, this took like no time to run. It ran really quickly because it didn't have to print out anything. So if I typed in maybe something like 100,000, like this, and then I said the same thing as before, and said print out X, then it would take a little bit longer. See, it's still running. So you can see how much longer it's taking, and we don't know how long it's going to take. It depends on the value of the variable. So we call that O of n. And an example of this is list.pop. So just from what we've learned before, can anyone tell me what list.pop does? Okay. Well, what list.pop does is if we have a list and like let's create a list and maybe this list is 1, 2, 3, 4. So what list.pop does is it just removes the value in a list. So if I said list.pop like this, so we removed the value 4. It removes the last value by default. So if I didn't type in anything here, it would remove the last value in the list. So now if we looked at what contents are in our list now, we'd only have 1, 2, and 3. So if we did list.pop at the end like this, so to access a value in a list, this is, well, first of all, does anyone remember how I'd access a value in the list? So let's say I want to get let's say I want to get this number 3 here in the list. What would I type in? I type in list and then the index value, right? So list 2, like this. And then this would give me the value at the index 2. So here's 0, 1, 2. So 2 here. So it would give me this value. And that's how I'd return this. And to get a value in a list, this is O of 1 efficiency. So this is very efficient. But let's say I wanted to pop the value of list.pop. And then let's say I wanted to pop the value at index 0, like this. So this would be O of n. Because why would it be O of n? Because, okay, well, let's look and see what this does here. So if I did the list.pop 0, and then if I looked at the list, now we have 2 and 3 here. So recall before that here, 2 is in the index 1. But now here 2 is in the index 0 of the list. So what this does, list.pop 0 does, is it just removes the value from the index 0, which in this case is 1. And then after we remove this value, what we also have to do is we have to shift the other values in the list to fill up the rest of the list. So we take the values 2 and 3 here and just move these to occupy the position that 1 was just in. So in this case, 1 was in the position 0, the index 0. So now that 1 is gone, we just moved the number 2 down. And then once 2 got moved, we had to move the next number, which was 3. We have to move that to occupy 2's spot in the list. And then we just continue that until we finish the entire list. In this case, the list was just 2 numbers, so that's why it didn't look like much. But if I had maybe something like 1, 2, 3, 4, 5, 6, 7, 8, like that, whoops, like this, and then so now our list is that. And if I said list.pop and then the value 0 here, so what we do is we'd remove 1, and then we'd move all of these values, we'd shift them over to the left 1, like that. So now our list, so now basically the index of all these values decreases by 1. And since it depends on how long our list is for all of these, because in this case we'd have to shift 2 numbers down, but in this case we had to shift, 7 numbers down, and but the number that we have to shift depends on how long our list is, right? So that's why this would be O of n. So does everyone understand that? What O of n is and why list.pop 0 is O of n? Okay, does anyone not understand that and would like me to go over that again? Okay, so nobody said they would like me to go over that again. Does this work in Python 3.8? Yes, this would. However, I wouldn't recommend using Python 3.8 at this point because a lot of libraries, like Google's library. If you wanted to use one of Google's toolkit to create experiments in Python, Google's libraries do not, at least for now, they don't support Python 3.8. So that's why I'd recommend using Python 3.6 or Python 3.7 right now. And the last thing we have is Lestat Sort. So what this does is this just sorts a list. So let's say I had the list before, which was this, and maybe at the end here we have like, I don't know, -100 or something, right? 1000. So now our list is like this, and what the sort function does is this just sorts the values in our list. So if I did this, like that, now our list is sorted in ascending order, like that. And how this works is, well, we'll go over how it works later on, but the efficiency of this algorithm here is O of n log n, which if you're comfortable with the log function in math, then this should, maybe you'd understand this right now, but we'll go over it later as well. So now let's go through some practice problems. Okay, so go to your Python command line, CLI, or you can go to Google Colab, and then write a program to find the sum of all numbers that are multiples of 4 or 5 between 1 and 4 million inclusive, and then type your answer in the chat. And we'll see who can get this first. That being said, if any of you have any would like any help on this problem, if you're stuck or something, just type in the chat, say like, I'm stuck, how would I do this? And I'll see if I can understand what you're saying, and I'll tell you how you can fix your program to try to solve this problem. So we'll go ahead and just open Google Colab like this. And if I go here, I can create a new notebook, Python 3 notebook. And just type in a program here, or you can go to your Python CLI, or if you downloaded an IDE, you can go there too to create your Python program and try to solve this problem here. Once you're done, type your answer in the chat. That is all. Okay, so I want to check in to see how you guys are doing. So how's it going so far? Are you guys, do you think you're close to the answer? Do you think did you already give up? Or, so type in how it's going so far. Okay, so one person said close. Okay, we'll give it another 2 minutes.
Hanging by a thread, hung upon all the words you said, breaking free from every time.
Okay, so it's been 2 minutes. Did anyone get the answer? Type your answer in the chat. Okay, so this was the answer. Okay, well, if you aren't able to type it in the chat, just maybe this, if you got this, you're correct. Let's go through this together. So here I've opened Google Colab. And so the question was to find the sum of all the numbers between 1 and 4 million that are multiples of 4 or 5. So how I would do that is, or at least there are a couple of ways you could do this problem, but how I would do it is I would say for I in range, so 1 comma and then 4 million, but we want to include 4 million as well. So I would type in 4,000,001. What is that? Okay, so here I have 4,000,001 like this, and then now I'm going to check if I is a multiple of, if I is a multiple of 4 or 5. So does anyone remember how I would check if I is a multiple of 4? So yes, I'd use an if, but what specific operator would I use to check? Okay, yes, that's correct. So I %sign 4, and then if I said I %sign 4 is equal to 0, then if I is a multiple of 4, then this will be true. Okay, so that should be, hopefully make sense. So, or if I %sign, it was 4 or 5, yeah, 4 or 5. So if I %sign 5 is equal to 0, then that means that I is a multiple of 5. And then let's make a count variable too. So count equals 0. So if count, or if this is true, then we're going to increment count by 1. So count count plus equals 1. And then at the end, we'll just print out the value of count like this. Okay. So let's see what this gives us. Weird. This answer wrong. 1 in 4 million. Maybe this is the correct answer. This was a mistake. Okay, whatever. But does everyone understand what this program does here? We have a variable called count, and we, for I in range from I in 1 to 4 million in 1, we check if I is a multiple of 4, or if I is a multiple of 5, and then we increment count. So perhaps maybe this was a mistake. Maybe this is the right answer. Remember in Project Euler, when we did this first problem here, we used what was about the same program here as well. So here we have 4 million, I believe. So while count is less than or equal to 4 million, we're incrementing the sum by count. Oh, right, okay. So yes, this was a problem with the program. So count, we want to add I to count instead, like this. And here we do indeed get this answer. So yeah, that was the mistake. So that's why we get this answer here. So count, we don't want to increment this by 1. We want to increment it by I, because I is the value that is a multiple of 4 or a multiple of 5. So yeah, sorry about that. That was my mistake. Since we're doing this live, it's a little, sometimes I can make mistakes as well. So, but anyways, this is the correct answer. And remember, we used a similar process when we were doing Project Euler here. But this was when we were doing multiples of 3 and 5, and we were doing it only up to 1,000. And we used a while loop, right? We used a while loop instead of a for loop. This time we used a for loop. So that's why, but keep in mind we get the same answer, right? Yes, we get the same answer in both places. So that just proves how you can use a for loop and a while loop for the same task as well. Okay, so does everyone understand how I would solve this problem? How to solve this problem? Okay, so nobody's saying yes. Is there a specific part of this that you want me to go over again? Okay, let's walk through the entire thing just so you can understand it. So here I'm setting the value 0 in the value count, in the variable count. So count is equal to 0 in this case. And then for I in range 1 to 4 million and 1. So I is going to go from 1 and then 2, 3, 4, 5, 6, 7, 8, 9, all the way to 4 million. And then if I is a multiple of 4, or if I is a multiple of 5, so that's what this if statement is doing. So if I is a multiple of 4, or if I is a multiple of 5, then we're going to add this value to count. So keep in mind that this plus equals sign here is the same thing as saying count is equal to count plus I, like that. So what this is doing is this is just adding the variable I, or the value of I, to the variable count, like that. Just a shorthand way of writing this is count plus equals I. And then at the end of our for loop, after we reach 4 million, we print out the value of our variable count, and which gives us the answer. Okay, so does everyone understand this program now? Okay, yes. So that was our practice problem. Now let's go over the quiz. So I noticed that a few people did not do the quiz. So we're going to go over the first quiz from the first session. This should have been a really easy quiz. If you missed it, whoops, I'm going to open the quiz quickly. So this quiz was graded, and the average score was an 88.9 with a median of 90. The median score was a 90%, and our range was 78 to 98%. So let's just go through this quiz. So you'd answer those. And then in your own words, define what a Boolean and a string is, a float, a Boolean, an int, and a string, and a list. So remember we went over this, an int, how I would answer this is an int is a whole number, like that. And then I'd say a float is a basic decimal number in Python. And then a Boolean is a value that can either be true or false, like that. And then a string is a basic text, a data structure. Basic is a basic text data. And then a list is a structure that can store data. Okay, so if you took this test, then this was what you should have, this would have been an example of an answer that received a perfect score for this question. And then this next value here, 2 possible values of a Boolean in Python 3. So in this, you could have just wrote, you could have said 1, 0, because remember a Boolean can be 1 or 0, or you could have said true or false. But both of those are the 2 answers that you could have said, or you could have even tried to be a little creative and said something like true, 0, right? Mixing them, but all of those received credit if you did any of those. And then if you wanted to print out this string here, you type in print and then parentheses and then the string, which is don't tell people your plans, show them your results, like that. And then a mistake that a lot of people made was they actually capitalized the P in print. So you have to make sure that this P is lowercase. Which language runs faster? You should have known that Java runs faster. And then evaluate this expression in parentheses using the table. So this lower rows take precedence over higher rows. So that means we're moving from bottom to top. So let's go in this order. So binding or parenthesized expressions, we have a parenthesis here. So 1 plus true is 2, right? So this part of the, let's write like this. Okay. Just give that a second. So 1 plus true is, what is the value of 1 plus true? This is 2, right? And then next we have the power sign. So we did this first row, and now the second row, subscription, slicing, call, attribute reference. So there's none of that in this expression, so we can just skip this row. And then await x, we don't have the word await in this expression either, so we can skip that. Then we have the power, the exponentiation. So 7 to the second power is written like this. So this part over here is the same thing as 7 squared, which is equal to 49. And then next we have positive, negative, bitwise, not. We don't have any of that in this expression, so we can just skip that. And then we have multiplication, division, and floor, and then the remainder operator. So for this, we can just use the, so let's see, do we have any of that? Yes, we do. We have division, the floor, and the multiplication. So since this is all in the same row, we move from left to right. So first 8 divided by 2, we first do this part here. So 8 divided by 2 is 4. And then 4 floor 10. Just to test, does everyone remember, if everyone remembers the floor? So what would 4 floor 10 do? So 4, and then the floor function, which is this, 4 floor 10. What would that do? Type it in the chat. What would that be? If I said 4, and then floor, and then 10, what would this be equal to? So this is just the remainder. So 10 does not go into 4 any number of times. So this would just be, what would this be? If you wanted, you could even open this up and then type it in here, right? So can anyone tell me what would 4 floor 10 be? Type it in the chat. So 4 floor 10 is equal to 0, right? So 4 floor 10, this whole part of this expression would be equal to 0. Whoops. Would be equal to 0 here. So let's erase. Okay, so this highlighted part is 0, and this part is, what is this part? This part is 2. So let's write this here. We have 49. We have 0. We have 2. And then next we have the multiplication. We have a multiplication sign here. So 2 times 0 is just 0. So now we're evaluating this whole part. So 2 times 0 is just 0. And let's write a 0 here. So this whole part is 0. And then 49 plus 3. Well, now we've checked off this part of our expression. So now our next row is this row, plus and minus. So we have 49 plus 3 minus 0. So 49 plus 3 is just 52. So 52 minus 0 is just 52. So the value of this whole expression would be 52. And that was the correct answer of this specific question here. Okay, so the correct answer for this would have been 52. And then name 5 companies that use Python. This could have been pretty much anything. Most companies use Python. I can't really think of that many companies that don't use Python. So this should have been hopefully pretty easy. And then this is also pretty subjective, depending on what your goals are for this class and so on. So now let's take a look at the other quiz that was due yesterday. So keep in mind, we are grading these quizzes, and grades will be taken, they are being recorded. So, so the average for this last quiz was lower than the last quiz. Here we had an average of 80.1%. And keep in mind that just because there was a low average, there were some people that did get perfect scores on this quiz. You'll find out later on if you got a perfect score or not. But anyway, let's just walk through this whole what the last quiz was like. So this last quiz was just 5 questions, and all of them were free response. So they were also pretty open-ended. And in my opinion, these should have been pretty easy, pretty simple. So this one, write a Python program that will print out the sum of all the even numbers between 1 and 100, inclusive when run. And this can be done in 1 line. So how I would do this is, well, can anyone type in the chat how I would answer this question? What you think the correct answer would be? Okay, so I would type in sum and then range, right? because this is how we can find the range, the sum of sequences. And we want the even numbers. We want the numbers between 1 and 100 inclusive. So keep in mind that this is including 100 as well. So 1 comma 101, like that. And then we want the even numbers. So if I did something like, if I typed in a 2 here, then this would give me the odd numbers, because we're starting at 1, we're adding 2, right? So 1 plus 2 is 3, 3 plus 2 is 5. That's not the even numbers, those are the odd numbers, right? But so we type in a 0 here. So this would be 0 plus 2 plus 4 plus 6 all the way to 100. And then we stop. And what this does is this just finds the sum of the values here. So this was the correct answer for this question here. Now this next question, write a Python program that will print out all the even numbers between 1 and 100 inclusive in ascending order when run. So this should have also been pretty easy. So for I in range, and then between 1 and 100, so 1 comma 101, like that. And then if I typed in 2, again, the same thing will happen. If I did this, right, then I'd be getting the odd numbers. We'd start from 1, and then 1 plus 2 is 3, 3 plus 2 is 5. Those would be the odd numbers. So we're going to start at 2 instead. So 2, because 1 isn't an even number anyway, so we wouldn't be printing it out, even though it says inclusive here, because we want to only print out the even numbers in this sequence. So what I would do next is I would type in print and then print I, and this would print out the numbers between 1 and 100 that are even in ascending order. So the next one, this got a few people. Some people seem to be more confused about this. Print out all the even numbers from 1 to 100 in descending order. So what this meant is, so descending order, in case you don't know, is these are the numbers from 100 to 1, but counting down. So how I would do this is I would say for I in range, like that, and then we're starting at 100, and then we want to go down to 1. So I would say 100 comma 1, like that. And we're counting down by 2. So this would be minus 2. So we'd start from 100 and then subtract 2. So this would be 98. 98 subtract 2, this would be 96, and so on, right? And then I just be print out I every single time. And this would print out the numbers from 100 to 1 in descending order that are even. I'm going to run this just to show you. And you can see here, we start at 100, and then we print out the even numbers in descending order. And then this next one, so write a Python program that will run with big O complexity of O of n. So this was more open-ended than the other ones. I could easily do this by saying input, and then say something like type in a number, like this. And then I'm taking in a number, so this is going to be an int, and then let's call it I, like that. And then for, or no, let's call this X, because we have I here. So for I in range, and then X, for I in range X, we're going to print out I, right? So this, we don't know just by looking at this program what this will print out, because it depends on what the person that is running this program types in. So if I type this into JGrasp here, just clear this and copy and paste this like that, then it depends on what number I type in. So if I typed in 10 and then hit enter, I get these numbers, and it would run in a certain amount of time. But if I typed in, like, 1,000 or 10,000, and then I get more numbers and it would take longer to run. So that's why it would be O of n. And then for the last question, write a Python program that will run with a big O complexity of O of 1. So this was pretty, this should have been really simple. You could have said something, you should have just wrote something that will run in the same, time every single time it's run. So if I said for I in range 10, and then let's say I said print I, and remember we need to space everything correctly, so like that. So this will always print out the same thing every single time we run it, right? It will print out the letter I 10 times, and so that's why this would be O of 1 efficient. So another thing to keep in mind when taking these quizzes, please do not Google for the answers. We have found some people that did Google the answers for these quizzes and just copied and pasted those answers. And keep in mind that these, we're using the honor system, and just use your own integrity to answer all of these honestly with your own work. If we do find out that you copied and pasted the answer from somewhere on the internet, then for that specific question, you will get 0 points. So just keep that in mind. And so why take all these quizzes and earn all of these points? Please, well, that is because we have created a ranking system where we will be ranked. It's like sort of like a leaderboard. You can think of it that way. So what this leaderboard will do is this will rank everyone in the class, and then if you reach like a certain, so what we have is we have levels. So just by completing quizzes and getting questions correctly, coming to class, attending the classes, if you do all of that and you do well in that, then you'd be moving up different levels. So right now, if you didn't attend any classes and didn't do any quizzes, that's fine. Just make sure you do them starting from now on. And if you reach like a certain level at the end, at the end of all of our 9 weeks, then you'll be getting your certificate for the class. So just keep that in mind. If you want to earn a certificate, if you haven't, if you're just watching like a recording and you haven't taken any quizzes yet, that's fine. You can still earn a certificate if you try your best and participate more now on. You'll also be learning more about Python, and that way we can accommodate our classes according to what you know, and to give you the best, to help you understand Python the best way possible for you. So we'll be sending more information about all that by email. So be on the lookout for that. Make sure you check your email. So this was that's the end of session 3. Hope you enjoyed. If you have any questions, as always, please email us, no matter what the question is, and we'll respond. So thank you for attending. Hope to see you next week.